Hello and welcome to the Sales and Solution wireless part. I would like to introduce you some information about wireless. So in the first few slides, I will show you some quick facts. The average user checks their phone 85 times a day, or equates to approx 5 hours a day. If you realize or if you want to check it for yourself, then just try to count how many times you watch on your smartphone or tablet or laptop. So at the end, when I wake up, I check my phone, check my emails, messages, whatever. So it takes some time if I read all the short messages I got, and so my day will start. By 2020, 7 billion businesses will be connected to the internet. That means that over 20 billion devices connected to the internet, not just by phone, also by tablets or by smartwatches, whatever can be connected through the internet. Where we got internet access or Wi-Fi, at the end we got it everywhere. So the question is where we don't have any Wi-Fi spots. So here are some examples like hospitals, restaurants, cafes, warehouses, or all the other things you can see on this slide. Every type needs a wireless connection. So which management types of wireless we are offering as Zyxel? We have 4 segments. We have the Nebula Professional Pack. This is a centralized management with added functionality, all the benefits of Nebula free with additional features and functions to help with larger deployments or larger management teams. So Nebula Professional Pack is an add-on to the Nebula free version. You have to license your devices or your features, and then you can use Nebula Professional Pack as a centralized management with added functionalities. Then we have the Nebula, we also call it Nebula Free. It's a centralized management, easy to use central management that suits typical configurations, deployments with the need to install software or a controller. So in this case, you don't need additional devices or additional costs will come up because everything is centralized via web browser on the cloud. So it's an easy management, and the configuration that you want to have are typical configurations like creating an SSID, the pre-shared key, or the pre-shared key with 802.11x. So this is what Nebula gives you for free on this centralized management. Then the typical installation, it's a standalone, so it's a single per device management, easy to use configuration that can be applied locally to each wireless access point via a web server. So if you have 5 devices on wireless APs, then you have to configure it 5 times and not on one centralized management. The last option that we offer you as Zyxel is a controller mode. On-premises centralized management. Hardware controller either dedicated or utilizing the USG's controller. This method allows really refined configuration for more complex installations. So in this case, you only have one centralized web browser or on-premise device where you have to set up your configuration like SSIDs, pre-shared key, security, whatever, and the configuration will be pushed to every access point that will be installed in your environment. There comes up a lot of questions about what is 2x2 or 3x3, what's the difference? Yeah, in this slide, we want to show you the difference. The first number is the number of transmit antennas, while the second number refers to the number of receive antennas. For example, our WAC 6503D-S AP is a 3x3, which means that it has 3 transmit antennas and 3 receive antennas. Sometimes you will see a third number at the end preceded by a colon, e.g. 3x3:3. The last number refers to the number of spatial streams, the number of independent wireless data transmission that are sent over the antennas on the same channel. Performance to client devices. Yeah, so the performance benefits are clear when you have a 3x3 access point paired with a 3x3 client device like an Apple MacBook Pro. But what about a 1x1:1 device like the Apple iPhone 8? In this case, there are no MIMO gains from the additional spatial streams. However, there are still some performance improvements to be had with a 3x3 AP versus a 2x2 AP. Another good question that always comes up, how many devices can you get on one AP? Most vendors will display the physical association count possible by the chipset. Just like the maximum speed, this is theoretically. In a real-world deployment, it comes down to what the individual requirements are. For example, density and type of devices, application requirements, what are the speeds that you required, coverage area required, interference and obstructions and signal on site. Just to name a few of these things that can happen, or you have to think about how many devices can you get on one AP. So it also depends on your environment and your special needs. Real world limitations. So we are not only in a dream, so there are also some real world limitations on the wireless part, and the magic word is airtime. Airtime, what a single access point can support with clients at minus 67 dBm, 5 gigahertz, 20 megahertz. So 75 up to 80% airtime utilization is the maximum that can be physically achieved. 100% cannot be achieved due to overheads in Wi-Fi standards. Wi-Fi advertised data rates versus actual throughput is only part of the problem. Years ago, people planning their wireless networks, they would focus primarily on coverage. Whilst coverage is important, and without coverage, you don't have a network, but you have to make sure that this is usable coverage, or as we refer to it, the quality of wireless. As more users migrated to the wireless network from the wired network, the focus switched from coverage to user density and quickly changed to device density. Wi-Fi is now about focusing on airtime utilization, which is important for supporting not just the clients themselves, but the applications too. The frequencies we have available are limited. It's not like we can just add more frequency space as we need, more bandwidth by adding another cable. The airspace we have is the airspace. This illustration you can see shows the various radio technologies and client device traffic types along with the number of clients, which actually dictates how much you can really get out of an access point. In reality, you are never going to achieve 100% airtime utilization due to the overhead of Wi-Fi communication. 75 up to 80% utilization is really hitting the limit of what can be expected for the network in its current state. If you are doing any kind of voice over Wi-Fi, you need to plan for at least 50% of clean airspace. If you're looking at 50% utilization of a network to begin with before adding voiceover on top of it, then you're technically going to run overshot real deliverable quality of wireless. To combat this today with the current standard, you have to look at using more channels and have a smart channel plan to make this work. So here on the screen, you can see several devices, kind of types like a laptop, a tablet, or a smartphone. You can see the throughput, and in this case, you see the total airtime utilization on the numbers of devices you are using. The next topic I want to introduce is the smart antenna technology. And smart antenna is not beamforming. Beamforming is a process of steering RF energy to the station or client. This can produce constructive combinations as well as destructive combination signals. Beamforming with 802.11ac is explicit, which requires more frequent feedback between AP and the client using an expanded version of the channel sounding process to alter signal phasing in a higher effective power level was also more efficient with how comes on and off the air, which can effectively leave the RF open and more available. This does not actually make the network faster, just makes it feels faster due to being so much more efficient. So you can see on a 802.11ac Wave 2 second gen TX beamforming, the improvements in low end sensitive can gain up to 15% in throughput. So I want to show you in the next two slides the difference between single unit MIMO and multi-MIMO, so the difference between AC and Wave 2 access points. The single unit MIMO, you can see that every client will make a request to the AP and get feedback. So it's a kind of first come, first serve algorithm. On the multi-MIMO, you can see that the AP get a request from three devices at the same time and can handle this without any problems. So technically can increase 300% on Wave 2 multi-MIMO access point. The challenges of wireless in today's environment. So there are some things you have to think about, or maybe you were conflicted on some projects, and the question is, have you ever experienced on these cases? Just think about it and you will ask you at the end why. In a high user density environment, adding new AP doesn't improve performance. So the question is why? Just think about it, and maybe you already know the answer, but if you extend your environment and you want to put some new APs in the environment, in the existing environment, you have to reallocate some existing APs. Even with one AP in each classroom, students struggled with slow download speeds. You have to think about high density environments. So you have one AP in a smart classroom and you have 25 pupils in the room that are using the Wi-Fi at the same time. So they're struggling with slow download speeds, because just think about a single unit MIMO or multi-MIMO. So this will take time and slow the speed. So the best way is to put two devices in each classroom. This would be the best way or efficient way to solve this problem. You've invested in new technology, but you haven't seen the performance or improvement you expected. Yes, sometimes you checked or realized this, make some analysis, and at the end, maybe there's a misconfiguration in there or some other things you have to clarify or change, and then everything works fine. So that you also think new technology is now it's much more better than before with the old environment on devices. In an office environment, you have come to expect that video conference will often be interrupted. Yeah, so this is more or less a misconfiguration. You just have to think about to put your video conferences in a different SSID where no other devices are connected, and then you put a quality of service on this SSID for better voice or video quality. Do you worry about having to provide wireless at a conference or 100 of users? Yes, so if you are in a high density environment, you have small conference rooms and a lot of people were in there, then you need to check out that everything works fine, that everybody has enough throughput, or the bandwidth is fine. So these are things you have to struggle with it and just to think about it. And always the question is why. One answer on this is the channel. So on the 2.4 gigahertz spectrum, you have 14 channels, 3 channels on 20 megahertz or 3 channels are non-overlapping, and it's each half circle is 20 megahertz. On the 5 gigahertz Wi-Fi current spectrum for UK and for Europe, you can see that with 20 megahertz on the 802.11a, you have 19 20 megahertz channels, 4 usable without DFS. On the 40 megahertz, that's 11.n, you have 9 40 megahertz 2 usable without DFS. On the 11AC standard, you have 4 80 megahertz, 1 usable without DFS. And on the Wave 2, you have 2 160 megahertz and 0 usable without DFS. So what's the issue? To achieve faster speeds, greater channel widths are needed. This in turn means less channels to use. We are then faced with co-channel interference. So the question is, what is co-channel interference? Co-channel interference occurs between two access points that are on the same frequency channel. The reason why this should be considered when deploying Wi-Fi is that co-channel interference can severely affect the performance of your wireless LAN. So much so that the effects can make the service unusable. Here you can see on an example CCI, so co-channel interference is like two lanes merging on a motorway without knowing it's going to merge. Or if I had a conversation with one guy, when we talk to each other, everything is fine because I can understand him and he can understand me. But when the environment changed, a lot of more people were standing next to us and were also having a chat, then it's not easy to understand my partner when we are talking because the environment completely changed. It's getting louder, and so it's not easy to understand. So this is also a kind of co-channel interference. Traditional methods of dealing with co-channel interference, what you have to do, maybe turn down the power. Yeah, if you turn down the power, then traditional methods of dealing with co-channel interference issues is to turn down the power, as I mentioned. Unfortunately, this causes dead spots due to less coverage area and no overlap, along with giving lower throughputs. Also, it doesn't completely remove the co-channel interference issues. Yeah, so turn down the power is not the right way. The smart antenna that we are built in our access points, there are some quick facts: increase capacity, focus the transmission of the radio to achieve an increase in capacity, then increase coverage, increase the signal gain, allowing increased coverage, reduce interference by shaping a pattern away from interference reaction, we are able to reduce interference. Green solution, power efficiency in the smart antenna means we are able to reduce the power consumption that's needed. And it's for all devices, new and old, and 2.4 and 5 gigahertz. So if you also have some old devices from us that also included the smart antenna, all these features are also available for these kind of devices. But you have to be installed smart antenna in the device. What is a smart antenna and how does it work? Typically, a conventional omnidirectional antenna has no interference reaction. The pattern normally looks similar to the one shown. When an AP increases the output power to strengthen the signal, the interference noise is usually increased too. More interference or noise in turn makes the radio pattern unreliable in its ability to cleanly transmit and receive data. The alternative to an omnidirectional antenna is a directional antenna. As you'd expected, this focuses the energy of the radio into a particular direction, making it ideal for outdoor environments, point-to-point connections, or for more complex environments with specific requirements. This, however, is not an ideal solution for use in a traditional indoor environment, as it requires more physical equipment and is far more complex to plan and manage. For example, to cover 360 degrees, we would need to use something like 4 by 90 degree antennas and 4 access points. It is also more prone to having dead spots closer to the antenna itself. The smart antenna technology works like this. The smart antenna scans for clients and interference. So you can see in the top of the screen, the Wi-Fi client, and the bottom, there's a microwave, and the AP starts to scan for clients and interference. Intelligent algorithm selects from over 700 optimized antenna patterns. This cycle takes less than 100 milliseconds. Optimal beam combination is shaped for each client. Here you can see a different example. The cycle is repeated if necessary to dynamically shape different patterns in response to changing environment. As an example, the client station moves or interference is detected. So the patterns or the smart antenna is always working in the access point to get the best result for the client or for the station. We also did the outstanding performance test. Yeah, as you can see here, we have an auditorium. We use this auditorium in our headquarters. We put the AP on the wall. So nearby the wall, it's called AP, and we have 4 locations for the measurement. The P4 location is 30 meters away from the AP. We did this outstanding performance test also with different vendors. As you can see here, you can see the throughput by each location from each vendor themselves. Here is the outstanding performance on the 5 gigahertz throughput. Yeah, you can see the location 4, which is 30 meters away from the AP. We performed much more better than on P3. Downloading benchmark for a WAC 6503D-S. You can see on location P3 outperforms competitors at locations P3 with 60 megabit per second throughput, and on location 4 we are 65. Yeah, so this is what I mentioned before. We are much more better on P4 than on P3, and on P4 some competing models are failed at the location P4. This research we did not only by ourselves. The networking group University of Brescia did this in Italy, so you can see the URL, and they did the performance tests and the tests completely free from us or from other vendors. You can see the devices that are put under the test. Yeah, it's from Zyxel, Aruba, Ruckus, and from Cisco. You can see here the types, the different types of devices, what was the model, what was the spec sheets like AC 3x3 column 3 or dual radio smart antenna technology. You can find everything on this slide. What are the specs from the devices that the network group in the University of Brescia was testing? The networking group, University of Brescia, Italy research, you can see the results. We are 70% better in co-channel interference prone environments. We are 56% better coverage when comparing our AP against Cisco in 5 gigahertz, and we are 45% better than other smart antenna vendors. Wireless designed for the ultimate user experience, refined, tuned, and robust hardware is key in creating the ultimate user experience. Access points are backed by a lifetime warranty. So lifetime warranty means end of life plus 5 years on top. So here's the portfolio of our access points. As you can see here, we are talking about the NW1123 series. It started with ACV2. It looks like a smoke detector, and the spatial streams are 2x2. And the NWA1123 AC Pro has a 3x3 spatial streams. And the interesting thing on this 1123 AC Pro is that you can choose wire dip if the access point is wall mounted or ceiling mounted. So we turn on off some antennas in the device themselves to get more throughput or to get more coverage. The NWA 1123 ACHD is our first wave 2. access point or entry access point for wave 2. As you can see, it's multi-MIMO on the antennas and 3x3. So the throughput, it's nearly 1.6 gigabit per second. And as I mentioned, it's the first wave 2 entry AP in our series. The NWA 1302 AC, it's a wall mount AP, and it's really popular in hospitality section because next to the wall mount AP, there is also 3 copper cable ports. You can use them as a switch as well. Yeah, one port also include a PoE. So it will deliver a 9.6 watt PoE on this port. So you can link or connect a IP phone or some small PoE devices as well, or you can connect your smart TV as well for IPTV scenarios. One more thing I want to clarify, these APs are normally in standalone mode, but they also have the Nebula Flex firmware. So that means next to the standalone mode, you can also move them into the Nebula control center, and you can have a centralized management of these AP on the web browser. Here are the dedicated Nebula access points. So this means that you can only configure, monitoring, and manage them over the Nebula Control Center. Yeah, it's NAP 102, NAP 203, NAP 303. The 303, it's also good for high density environments. And the NAP 353, it's an outer access point. And what you need is, or what is required are external antennas. You need 6 external antennas for configuration or for expanding the Wi-Fi signal on this device. As I mentioned, it's only managed by the Nebula Control Center, so no other chance to manage these devices. Our business class access points are the NWA 5123 AC, then the 5123 AC HD. This is also a Wave 2 access point, and the WAC 5302 D-S, it's the wall mount access point with additional copper cable ports. And then we have the WAC 6103 D-I. This also includes the option for wall mount or ceiling mount installation. Then we have the WAC 6303 D-S series. It also included the Bluetooth option, so you can use the Bluetooth beacon for triggering guests on their Bluetooth. This is an optional thing and which is built in the AP. The 6303 D-S, it's also Wave 2 access point. It also has the multi-MIMO antennas. And so this is the last device of our Wave 2 series. The WAC 6503 D-S is a AC standard, single unit MIMO antennas are built in, and it's also like the NAP 303, really good for high density environments or for logistic halls. WAC 6552 D-S, this is also an outdoor access point. Smart antennas are built in there. You don't need additional external antennas. Yeah, so it's a smart antenna, dynamic smart antenna technology. It's built in, and no additional antennas needed. So this is also an outdoor access point. We launched it last year, mid of last year. At least we have the WAC 6553 D-E. This is also the outdoor AP, but then you need the external antennas, and it also includes a heating system as well. To all the APs, we have the opportunity also to have an on-premise and centralized controllers. I want to show you the on-premise and centralized controllers in the next slides. So all-in-one wireless controllers, yeah, the APC controller or AP controller are built in the VPN series, UC series, and ATP series, yeah. On the VPN series, as you can see, it started with the VPN 50, VPN 100, VPN 300, and UC 2200 minus VPN. If you are deciding to use these devices as an APC, we give you 4 AP license for free, and then you can see the limitation, how big your environment could be. As you can see on the VPN 50, the limitation is 34 access points, on the VPN 168, and on the VPN 300, 138, and on the UC 2200, 258 APs. On the UC series, you can see we started with the UC40, W and UC40, UC60, UC60W, UC100, 210, 310, 1100, and 1900. And as you can see, on these series, we gave you 2 AP license for free, and the limitation, you can see it's 18, 34, or 130 APs. On the ATP series, at the moment we have three devices. So it's ATP 200, 500, and 800. And on these devices, they are bundled with a 1-year Gold Security Pack license. And in this case, you will get the whole number of APs you can use. So 18, 34, or 130 APs. If you're using Device HA Pro in your environment, that means you have an active passive security or firewall configuration. That means you have 2 firewalls from the same model in your environment. Then you can see these are the devices that can support Device HA Pro, and you only need to have one registration on the license for the APs on one security firewall, because when the first firewall went down, the license will swap to the second device and your wireless environment is still running. We also have on-premise and centralized wireless controllers. These are the 2 models. It's the NXC 2500 and the NXC 5500. The NXC 2500 is fanless, and the important thing is from factory default, we gave you 8 APs license for free, and the limitation is 64. And on the NXC 5500, we gave you 64 APs, and the limitation is 1024 APs you can manage over this unit. Here are some features. So it's a scalable controller, scale from controlling 8 APs on the NXC 2500, max 64, up to 1024 APs with the NXC 5500. AP auto-healing detects status of neighbors' APs and adjusts AP power automatically if an AP fails to cover the void area. Wireless mesh technology, Zy-Mesh extends Wi-Fi coverage in difficult-to-reach locations. Each repeater AP also has multiple route selections to provide non-stop Wi-Fi services. Client band steering sets 5 GHz as priority for dual band devices to overcome heavy loading on the 2.4 GHz band. Client isolation. By using layer 2 isolation from each AP, we can ensure that neighboring clients are not able to see each other. Zero AP config deployment means auto-deploy APs with SSID, security, profile grouping, VLANs, and much more using our auto-deployment protocol AP flags. So you only need to make one configuration on the wireless controller and the deployment will be pushed to all the APs in the existing environment. Then we also have intelligent dynamic channel selection, advanced intelligence on channel management against to avoid interference automatically. Then rogue IP detection and isolation, detect and isolate, contain rogue IPs within the controller for security and stability of the wireless network. Radius and AD integration. Yes, we also offer the authentication and create policy objects based on user and groups. We offer Radius, Active Directory, LDAP, and local. We also offer a captive portal. It's a control access by presenting a captive portal page both on the NXC and via an external portal. So you have also the option to use an external portal. You just have to fill in the URL to this portal and it will be redirected to your external portal page. Advanced IP load balancing, including our own smart classroom feature, fast roaming 802.11r, fast roaming deployment on NWA 5120 series and WAC 600 series with WPA or WPA mixed security mode. Net transversal ability to facilitate the connections traversing net gateways to solve connection issue for AP and wireless controller. Local bridge and tunnel mode allows AP to offload locally or tunnel to the controller to suit your environment. Security at the edge includes industry standard WPA Enterprise with 802.1x authentication, along with the Extensible Authentication Protocol, EAP, frameworks, and built-in firewall features. Client signal management create boundaries that allow you to take control of clients when they are allowed to connect, disconnect by their distance from each AP. Scheduling task, build and schedule to allow you to run scripting tools to help you customize the APs in your environment, or you can also use it via broadcast the SSIDs on special dates. Dynamic VLAN allow dynamic VLAN assignments to wireless clients based on user group information configured in the radio server. This was my presentation. I hope you enjoyed it and I wish you all the best. Thank you.